Welcome to the class, students. I am here to teach you chapter 11, force and pressure. Let's warm up. Write push or pull. So students, look at these activities. You have to write the here push and pull for these situations. Let's know about force. Force, a push or a pull. Forces are due to an interaction. Types of forces. Pressure exerted by liquid and gases. So student, these are the topics we are going to read in this chapter. Here is force. An object either remains in rest or in motion. How an object in rest comes in motion and an object in motion comes to rest. It is force which is responsible for these actions. In order to understand force, let us think of the following facts. What do you do to make a football move? What do you do to make a moving ball move faster? Why does a ball rolling on the ground slow down and finally comes to rest? How does goalkeeper stop a ball? How do fielders stop a ball hit by a batsman? How does a hockey player change the direction of moving ball with a flick of the hockey stick? So students, you can think about these situations and then you find that all of these things is happened because of force. In all these situations, the ball that means an object either comes in motion from rest or becomes in rest from motion. The ball is either made to move faster or slower or its direction of motion is changed. Force is the factor which is responsible for all these actions. Force has been applied on a ball kicked, pushed, thrown or flicked. Let us explore more. So student, in सब situations में क्या हो रहा है? Force apply हो रहा है. Look at the pictures. A goalkeeper saving a goal. B, a fielder stopping a ball. And C, a hockey player flicking a ball. Here, force, a push or a pull. In our day-to-day life, we come across several actions in which force is involved. For example, when we lift a bucket of water from a well by pulling the rope tied to the bucket, we are applying force to lift the bucket. Then, when we are shutting or opening a door, we are applying force on the door. We are pushing or pulling a drawer, we are applying force on the drawer. So student, ये कुछ activities हैं जो हम daily life में करते भी हैं और क्या कर रहे हैं हम इसमें force apply कर रहे हैं. Here we have an activity. Activity 1. Identifying different actions as push or pull. Give some examples of familiar situations involving motion of objects. You can add more such situations or replace those given here. Try to identify action involved in each case as a push and or a pull and record your observation. One example has been given to help you. When we are fixing a nail into a wall by hitting the nail with a hammer, we are applying force to the nail. When a batsman hits a cricket ball, he is applying force. When a football player kicks the ball, he is applying force on the ball. When we squeeze a lemon piece to bring out juice, we are applying force on the lemon piece. In horse cart, the horse pulls the cart by applying force. If we carefully examine all these actions, we find that we are either pushing or pulling the object. So we can see that in every action of pushing or pulling an object, force is involved. In science, a push or a pull on an object is called a force. Thus, we can see that the motion imparted to objects was due to the action of force. So students, in science, force क्या है? Push or pull. Do you notice that each of actions can be grouped as a pull or a push or both? Can we infer from this that to move an object, it has to be pushed or pulled? In science, push or a pull on an object is called a force. Thus, we can see that we learned in class 6 that a magnet attracts a piece of iron towards it. Is it attraction also a pull? What about repulsion between similar poles of two magnets? Is it pull or push? अगर हम मैग्नेट की बात करते हैं तो अट्रैक्शन शो करती है. सो क्या वो पुल है? और जो मैग्नेट्स जो है रिपल्शन शो करते हैं, क्या वो पुश है? तो we have to discuss these points here. Unit of force. The SI unit of force is Newton and in CJ system the unit of force is dyne. 1 Newton is equals to 105 dynes. Effects of force. A force may make the following effects when it acts on an object. So students, अब हम पढ़ेंगे force के effect. The first we have, a force may change the state of rest or of motion of an object. When a football player kicks a stationary ball, the ball comes to move. That means if the state of rest changes to state of motion by the action of force, when a moving football is stopped by a goalkeeper, its states of motion change to state of rest. So students, force apply करके हम state of motion को change कर सकते हैं. Here, a force can change the speed of moving object. If a football player applies a force on an already moving ball in the direction of the movement, the speed of the ball increases. Thus, a force can change the speed of the moving object. Let us see how a force changes the state of an object. That means how an object in rest comes into motion, how the speed changes, and how an object in motion comes to rest by the application of force by performing the following activities. We have to perform some activities, and by these activities you can understand how force works. Here we have an activity. Activity 2. Choose a heavy object like a table or a box which you can move only by pushing hard. Try to push it all by yourself. Can you move it? Now ask one of your friends to help you in pushing it in the same direction. Is it easier to move it now? Can you explain why? Next, push the same object but ask your friend to push it from the opposite side. Does the object move? If it does, note the direction in which it moves. Can you guess which one of you is applying a larger force? Look at these pictures. So that's how, students, you have to perform this activity. You can do it by yourself. Two friends pushing a heavy load in the same direction B in the opposite direction. Here, look at this picture. The rope may not move if the two teams pull at it with equal force. Now we have an activity again. Activity 3. Take a rubber ball and place it on a level surface such as tabletop or concrete floor. Now gently push the ball along the level surface. The ball will move. Push the ball again while it is still moving. You will see that the speed of the ball will increase. Next, place your palm in front of the moving ball. Remove your palm as soon as the moving ball. Does your palm apply a force on the ball? The speed of the ball will decrease. If you hold the ball, it will stop. That means it will come in rest position. Look here. A ball at rest begins to move when a force is applied on it. Here, conclusion. Application of force changes the state of an object from rest to motion and motion to rest. Force also changes the speed of an object. I have seen children competing with one another in moving a rubber tire or a ring by pushing it. I now understand why the speed of the tire increases whenever it is pushed. So students, these are some different activities you can perform by yourself. Here, a force can change the direction of motion of a moving object. In cricket, the direction of motion of ball changes when the batsman strikes the ball. Then, a force can change the shape or size of an object on pressing the shape of a sponge changes. When an inflated balloon is pressed between the palms, its shape changes. The shape and the size of a bowl of dough changes when it is rolled to make chapati. Thus, force can change the shape and size of objects. So, student, force shape or size भी change कर सकता है. Now, here, state of motion. The state of motion of an object is described by its speed and the direction of motion. The state of rest is considered to be at the state of zero speed. An object may be at rest or in motion. Both are its state of motion. So student, कोई भी ऑब्जेक्ट रेस्ट में भी हो सकती है, मोशन में भी हो सकती है. वो क्या है? उसकी स्टेट ऑफ मोशन है. Thus, we see that while a force may cause one or more of these effects, it is important to remember that none of these actions can take place without the action of a force. Thus, an object cannot move by itself. It cannot change speed by itself. It cannot change direction by itself, and its shape cannot change by itself. So student, कोई भी ऑब्जेक्ट ना अपना चेंज खुद में खुद कर सकती है, लाइक ना स्पीड चेंज कर सकती है, ना डायरेक्शन, ना शेप. वो सब किसकी वजह से होता है? फोर्स. नाउ वी हैव types of forces. Forces may be divided as contact force and non-contact force. The first we have contact force. In all the examples discussed so far in the chapter, the interacting objects have to be in contact with each other. For the force to come into place, such forces are called contact forces. So students, जब किसी object पे हम force apply करते हैं और वो उसको contact में आके करते हैं, so that is contact force. So we can say that contact forces are the type of forces that results when the interacting bodies are in physical contact with each other. Muscular force and friction are examples of contact forces. Let's us learn about some of these forces. Muscular force, the force resulting due to the action of human or animal body is called muscular force. So students, वो force जो human और animal body के द्वारा लगाया जाता है, that is muscular force. When we push an object like a school bag or lift a bucket of water, the force in fact comes from the action of our muscles, and hence such forces are called muscular forces. Animals also make use of muscular force to carry out their physical activities and other tasks. Animals like bullocks, horses, donkeys, and camels are used to perform various tasks for us. In performing these tasks, they use muscular force. So, student, animals भी बहुत सारे tasks में अपना muscular force use करते हैं. Look at this picture. Muscular force of animals is used to carry out many difficult tasks. Since muscular force can be applied only when it is in contact with an object, it comes under the contact force. It is the muscular force that enables us to perform all activities involving movement or bending of our feet. Here, friction or frictional force. In order to understand the friction or frictional force, let us consider the following situations of our day-to-day experience. A ball rolling along the ground gradually slows down and finally comes to rest. When we stop paddling a bicycle, it gradually slows down and finally comes to stop. A car or a scooter also comes to rest once its engine is switched off. Similarly, a boat comes to rest if we stop rowing it. When we switch off an electric fan, its speed gets slowed down and finally comes to rest. When we stop paddling a sewing machine, the speed of its needle gets slowed down and finally comes to rest. In all these cases, in fact, we are not applying any force from outside to seize the motion of the objects, yet their speed gradually decreases and finally they come to rest after some time. As the speed of objects gets slowed down and finally come to rest, it is obvious that there should be some force acting on the objects so that their speed decreases and the objects finally comes to rest. The force responsible for changing the state of motion of objects in all these examples is the force of friction. Whenever a surface moves or tries to move over another surface, the force of friction starts acting on the surfaces. It always opposes the motion of the objects. Thus, it is a force of friction between the surface of the ball and the ground that brings the moving ball at rest. It is the force of friction between the surface of the cycle tire and the ground that brings the moving cycle to rest. It is the force of friction between the surface of the tire of a car or a scooter and the ground that brings the moving car scooter to rest. The force of friction always on all the moving objects and its direction is always opposite to the direction of the motion. So students, जो हमारा friction force है वो direction of motion की opposite direction में work करता है, and the thing is that कि वो किसी दो surfaces के बीच में work करता है. Here we have non-contact forces, the forces which come into play without coming of the objects in contact with each other are called non-contact forces. These are magnetic force, electrostatic force, gravitational force. So student, ये जो forces हैं ये किसी भी contact की need नहीं होती है. Okay, here we have first magnetic force. We know that unlike poles of magnets attract, push each other, while like poles of magnet repel, pull each other, the magnet also attracts the magnetic substances. For example, a magnet attracts iron nails. The attraction of magnetic objects by a magnet and the attraction of between unlike poles of magnets and the repulsion of like poles of magnet are the examples of magnetic forces. So student, ये सब किसके example हैं? Magnetic forces के. These forces come into play without coming in contact with each other or without the contact of the magnet and the magnetic substances like iron nails. Thus, magnetic force is an example of non-contact force. So student, आप सबने भी ये सारे examples read किए. इनमें कहीं भी contact नहीं होता है objects का. That's why we call them non-contact forces. Here we have an activity. Activity 5. Aim to demonstrate magnetic force. Things required 2 bar magnets. Method. Take the magnets, place one magnet on the table, hold the other magnet in your hand and bring it closer to the first magnet. Record your observation. Observation: you will notice that when the magnet held in the hand is moved, the other magnet moves either towards it or away from it. Explanation: we have the magnets move away when like poles face each other. On the other hand, the magnets get attracted when unlike poles face each other. So students, as you know that like poles attract each other, unlike poles repel each other. So these are the example of magnetic forces. Now, electrostatic force, the force exerted by a charged body on another charged or uncharged body is known as electrostatic force. So student, कोई फोर्स जो लगाया जाता है चार्ज बॉडी के द्वारा किसी अनचार्ज बॉडी पे या किसी दूसरी बॉडी पे, दैट इज इलेक्ट्रोस्टैटिक फोर्स. This force comes into play even when the bodies are not in contact. The electrostatic force, therefore, is another example of a non-contact force. Activity 6. Take a plastic straw and cut it into nearly 2 equal pieces. Suspended one of the pieces from the edge of a table with the help of a piece of thread. Now hold the other piece of a straw in your hand and rub it free and with a sheet of paper. Bring the rubbed end of the straw near the suspended straw. Make sure that the two pieces do not touch each other. You will see that rubbed piece attracts the other piece. Next, rub the free end of the suspended piece of the straw with a sheet of paper. Again, bring the piece of a straw that was rubbed earlier with paper near to the free end of the suspended straw. You will observe that they attract each other. So student, you can perform this activity by yourself. It's very easy. You can perform it at your homes also. Here we have check and mate. You can do it by yourself as we already read about these things. Now we have gravitational force. A coin or a pen falls to the ground when it slips off your hand. The leaves or fruits also falls to the ground when they get detached from the plant. We know that the earth attracts everything towards itself. This property of earth is known as gravity. The force with which the earth pulls everything towards itself is called gravity. Gravity is not property of the earth alone. In fact, every object in the universe, whether small or large, exerts a force on every other object. This force is known as the gravitational force. सो स्टूडेंट, आप सबको पता है, अगर हम सबको पता है कि अर्थ के अंदर क्या है, ग्रेविटी है, इसलिए हर चीज वो अपनी तरफ अट्रैक्ट करती है. हियर वी हैव प्रेशर. द फोर्स एक्टिंग ऑन अ यूनिट एरिया ऑफ अ सरफेस इज कॉल्ड प्रेशर. प्रेशर इज इक्वल्स टू फोर्स डिवाइडेड बाय एरिया ऑन व्हिच इट एक्ट्स. सो स्टूडेंट, जिस एरिया पे फोर्स अप्लाई किया जाता है, दैट इज प्रेशर. This pressure depends upon the force and the area upon which it acts. As the force is in the numerator and the area is in the denominator, greater the force and smaller the area, greater will be the pressure. Let's try to understand the pressure by performing the following activity. So student, अब हम ये activity read करेंगे. इसकी हेल्प से हमें pressure को understand करने में easy होगा. Look here, we have an activity, activity 7. Try to push a nail into the wooden plank by its head. You could not succeed, but when you try to push the nail by the pointed end, you get success. From this activity, it is clear that greater the area, smaller is the pressure, and smaller the area, greater is the pressure. It's just a relation, opposite relation. That means अगर area increase होगा तो force decrease होगा. अगर area increase होगा तो pressure decrease होगा. अगर area decrease होगा तो pressure increase होगा. Here we have pressure area relationship can be seen in the following situations also. Broader strips are provided in the shoulder bags so that it can exert less pressure on the shoulder. Then iron nails, drawing pins, awl pins, etc. have sharper ends so that they can penetrate easily. The edge of all cutting tools like blade, knife, kachya, kurfi, etc. are made sharper so that due to lesser area, greater pressure can be exerted to work properly. Then camels can walk easily on sandy land because of their broader area. Then the rear wheels of tractors are made broader so that they exert less pressure on the soil and hence easily go through. Here we have pressure exerted by liquids and gases. Liquid and gases also exert pressure. Liquids and gases exert pressure on the walls of the containers. Let us see these in the following activities. So students, now we are going to read about the pressure exerted by liquids and gases. Pressure exerted by liquids and gases. Liquids and gases also exert pressure. Liquids and gases exert pressure on the walls of the container. Let us see these in the following activities. Look here, we have an activity 8. Take a transparent glass tube or a plastic pipe. The length of the pipe tube should be about 15 cm and its diameter should be 5 to 7.5 cm. Also take a piece of thin sheet of a good quality rubber, say a rubber balloon. Stretch the rubber sheet tightly over one end of the pipe. Hold the pipe at the middle, keeping it in a vertical position. Ask one of your friends to pour some water in the pipe. Does the rubber sheet buzz out? Note height of the water column in the pipe. Pour some more water. Observe again the buzz in the rubber sheet and the height of the water column in the pipe. Repeat this process a few more times. Can you see any relation between the amount of the bulge in the rubber sheet and the height of the water column in the pipe? Look here, students. Pressure exerted by water at the bottom of the container depends on the height of its column. So student, this activity you can perform in the presence of your teacher. Here we have an activity again, activity 9. Take a plastic bottle. You can take a discarded water or soft drink bottle. Fix a cylindrical glass tube a few centimeters long near its bottom as shown in. You can do so by slightly hitting one end of the glass tube and then quickly inserting it near the bottom of the bottle. Make sure that the water does not leak from the joint. If there is any leakage, seal it with the mouth of the glass tube within a rubber sheet. Now fill the bottle up to half with water. What do you observe? Why does the rubber sheet fixed to the glass tube buzz this time? Pour some more water in the bottle. Is there any change in the buzz of the rubber sheet? Note that the rubber sheet has been fixed on the side of the container and note at the bottom. Does the buzzing of a rubber sheet in this case indicate that water exerts pressure on the sides of the container as well? Let us investigate further. Again, we have an activity 10. Take an empty plastic bottle or a cylindrical container. You can take a used tin of talcum powder or a plastic bottle. Drill 4 holes all around near the bottom of the bottle. Make sure that the holes are at the same height from the bottom. Now fill the bottle with water. What do you observe? Does the water coming out of the holes pours at the same distance from the bottle? What does this indicate? Look at this picture. Liquid exerts equal pressure at the same time. And you now see that liquid exerts pressure on the walls of the container. Do gases also exert pressure? Do they also exert pressure on the walls of their container? Let's find out. I have seen fountains of water coming out of the leaking joints or holes in pipes. Supplying water, it is not due to the pressure exerted by water on the walls of the pipe. When you inflate a balloon, why do you have to close its mouth? What happens when you open the mouth of inflated balloon? Suppose you have a balloon which has holes. Would you be able to inflate it? If not, why? Can we say that air exerts pressure in all directions? Yes. Here, atmospheric pressure. You know that there is a air all around us. This envelope of air is known as the atmosphere. The atmospheric air extends up to many kilometers above the surface of the earth. The pressure exerted by this air is known as atmospheric pressure. So students, जो air pressure exert करती है उसको हम क्या बोलते हैं? Atmosphere की जो air है हम उसको atmospheric pressure बोलते हैं. We know that pressure is force per unit area. If we imagine a unit area and a very long cylinder standing on it filled with air, then the weight of the air in the cylinder is the atmospheric pressure. But how large or small is the atmospheric pressure? Let us get an idea about its magnitude. Here we have, when you press the shaker, most of the air between its cup and the surfaces escapes out. The shaker sticks to the surface because the pressure of atmosphere acts on it. To pull the shaker off the surface, the applied force should be large enough to overcome the atmospheric pressure. This activity might give you an idea about the magnitude of atmospheric pressure. In fact, it would not be possible for any human being to pull the shaker off the surface if there were no air at all between the shaker and the surface. Does it give you an idea how large the atmospheric pressure is? If the area of my head What 10 centimeter multiplied by 10 centimeter, how much weight of air would I be carrying on my head? The weight of air in a column of the height of atmosphere and area 10 into 10 is as atmosphere is as large as 1000 kg. The reason we are not crushed under the weights is that the pressure inside our bodies is also equal to the atmospheric pressure and cancels the pressure from outside. So students, जो हमारी body के internal pressure है वो atmospheric pressure के equal होता है. Here we have an activity 11. Take a good quality rubber shaker. It's look like a small rubber cup. Press it hard on a smooth plain surface. Does it stick to the surface? Now try to pull it out of the surface. Can you do it? Look at the picture. A rubber shaker pressed on a surface. Again we have a picture, pressure of atmosphere on your head. Do you know? Otto von Guericke, a German scientist of 17th century, invented a pump to extract air out of the vessel with the help of this pump. He demonstrated dramatically the force of the air pressure. He joined two metallic hemispheres of 51 cm diameter each and pumped air out of them. Then he employed 8 horses on each hemisphere to pull them apart. So great is the force of air pressure that the hemisphere could not be pulled apart. So students, this experiment done by a German scientist. Look at the pictures, horse pulling the hemispheres. Now what we learn in this chapter, we are going to discuss it in a nutshell. Force could be push or a pull. The SI unit of force is Newton. In CGS system, the unit of force is dyne. 1 Newton is equals to 105 dynes. A force arises due to the interaction between two objects. Force has magnitude as well as direction. When 2 or more forces are applied in the same direction, the resultant force is equal to the sum of all forces. When 2 forces are simultaneously applied in the opposite directions, the resultant force is equal to the difference of the 2 forces. A change in the speed of an object or the direction of its motion or both implies a change in state of motion. Here we have some keywords. Contact force. When the force comes into play because of the contact with objects. Muscular force, the force resulting due to the action of human or animal body. Force, a push or a pull on an object. Frictional force, the force generated by two surfaces that contact and slide against each other. Gravitational force, the force with which the earth pulls masses towards it. Magnetic force, the non-contact with which one pole of a magnet attracts the opposite poles or iron materials. Non-contact forces, the force applied to an object without being in direct contact with it. This is it from this chapter. Thank you students. We will meet again in the next chapter. Till then, revise what we learned today.